characteristics of fluids. Now we will discuss about the various energies possessed by the fluid particle. As we know, a moving body may possess the energy in different forms. A body may possess the energy by virtue of its position or by motion. But the liquids will possess three types of energies basing on the motion, basing on the position and due to pressure. So, the various energies possessed by the liquid are potential energy, pressure energy and kinetic energy. Before going for the conservation of principle of conservation of energy, at first we have to analyze what are the various energies possessed by the liquid particles. So, the energies possessed by liquids. The important forms of energy in a fluid flow are potential energy. As we know, it is the energy possessed by the fluid particle by virtue of its position or elevation from the reference plane. Second is the kinetic energy. As we know, it is the energy possessed by the fluid particle by virtue of its motion. There is the pressure energy. It is the energy possessed by the particle due to the pressure. Now we will discuss about these energies in detail. At first we consider the potential energy. As we know that the potential energy is the energy possessed by the fluid particle by virtue of its position or elevation with respect to a reference line. We know that if a liquid particle is z meters above the datum line, the potential energy of a particle will be z Newton meter per kg of liquid. Potential head of the liquid at that point will be z meters of liquid. So, from this reference line, if the fluid particle is lying at a higher distance, it possesses higher potential energy. From Pascal's law, the intensity of pressure is same at any point in all the directions. From there we are having an expression for intensity of pressure P at depth Z, that is P is equal to Wz, where P is the intensity of pressure, W is the specific weight and Z is the distance of the fluid particle from the reference plane. From this Pascal's law, we can have an expression for potential head Z, that is P by W. Now you observe this diagram. Here we are considering the datum as the reference line and a pipe or a conduit is there in which a fluid is flowing. Now we are considering three sections 1, 2 and 3. If we analyze the potential energy possessed by the fluid particle at these 3 points, let us take the point 1 which is at a distance of Z1 from the datum. So, the potential energy possessed by the fluid particle at 1 is equal to Z1 in meters. If we consider a fluid particle at